In this section, we will do the properties of logs. So let's do the first one. It's log of m plus log of n. So there are two log with numbers. They are when added, we can write single log with them. It is log of m plus log of n is equal to log of m times n. Now in this property, I have not written any base, but it's true if the base is same. For example, if there is some base a, so that a base with should be with every log. Log of an is equal to log of a of m times n. So if there is no base, that's okay. There should be no base on both the sides, left hand side as well as right hand side. But if there is base, it should be same on the left hand side as well as the right hand side. So I am writing without base, but these properties are true when the base is same throughout. So log of m minus log of n, when you have log some number and then negative sign in between and then log of another number, then it is equal to log of m upon n. So if it is log with positive sign logs, then there will be multiplication, and if there is a negative sign in between, then there is a division. Now as in base rule, we mentioned one thing. I'm just doing it here, explaining it here one more time. You can say, suppose I have log of 12 over 6. Now there is single log and this is a number with it. So you can cancel it and it can be written as log of 2. While in base rule, if it is log of a upon b, that was the base rule, it is log of b upon log of a. Then you cannot cancel a and b if there is a common factor. But in this property, because there is a single log, you can cancel it. Keep in mind this thing. Okay. Now let's come to the third property. Third one. It is log some base a m to the power n. Now be careful. It is n is power for m only. It's literally not equal to log of a of m to the power n. No. So you have to be very careful that power is on m only. That means on number only. Then it is equal to n log of a of m. Now let's use this property and the base rule together. Suppose I have log of 2 of 8, right? So according to base rule, it is log of 8 upon log of 2. But as we know, 8 is 2 cubed, so I can use that property here. So that is equal to log of 2 cube. According to property, it's 3. The power will come as multiplication. Log of 2 of 2. Now log of 2 of 2 is equal to 1. So that is equal to 3. If you apply the base rule, it's log of 2 over log of 2. So whole log of 2 is cancelled with whole log of 2. We cannot cancel the numbers a and b, but if this a and b are same, then log 2, if I write it, that will be log of 2 over log of 2. So that will be cancelled and it is equal to 3. So see how this property and the base rule are coming together to solve in a question with so much ease. Okay, that is third property. And fourth property is the next part of, you can say, third one. Suppose this base also has some power. Let's say that is m, right? And this number also has some power. Let's say that is n. Now base has its own power, only base. And this number has its own power, right? So then this n power over this m power will be multiplied n over m, and that will become log of a of b. Now let's again see a question where base rule and this property will come together, and the question will be super easy. Let's say my question is log of 8 times 16, right? So I know 8 is 2 cubed and 16 is 2 to the power 4. So let's write it log of 2 cubed times 2 to the power 4. So here 4 is at place of m property, 4 by 3. So this and this will be 4 by 3 as fraction, and that will be log of 2 of 2. Now log of 2 of 2 of is again 1. If you are a little bit confused over here, you can just go back to the base rule and check in how many different ways we can use that simple rule, right? So now that is equal to 4 by 3. Isn't it magical? Okay. Now property number 5th. Sometimes these properties are so much influenced by the base rule. Not influenced, but I should say both can be used together. Okay, so what is that property? 5th one. Okay, 5th property. Now, suppose I have log of a of b times log of b of a. Again, if you go to the base rule properties, here it is base and here it is log number. Here it is log number and here it is base. Everything covered. That is always equal to 1. So you can use it as a property. But if we see it with base rule thing, so log of a of b is log of b over log of a times log of b of a is log of a over log of b. So this whole log of b is cancelled here and whole log of a is cancelled here. So that is equal to 1. Now we are seeing which combinations give us as 1. So this is 1. Log of a is 1. Log of b of a is 1. Now let's see. If I have, suppose, log of a of b times log of b of c. Now here b is number, value, and here it is base. That's okay, that will be 1. But a is present as base, not as number, and c is present as number, not as base. So this will not be equal to 1, right? Now how that will work? So that is equal to log of b upon log of a. Just take it as a different thing, times log of c over log of b. So log of b cancelled. So that is equal to log of c over log of a. And if you just do the opposite of the base rule, that is log of a of c. So if you need the shortcut, right? So if value and base both are present, that will be cancelled. And what the result will be? Log of a of c. Log of a of c. So what is remaining? As it is on their places. So you have to be very careful while using this property, that whether is it equal to 1 or is it not equal to 1. That depends upon this condition. I hope that is clear. Okay. Now again there is a wonderful property. Suppose you have some base here, like a base and exponent, this thing, right? So base is a and log is present at exponent. So that is log of a of n. So suppose this base and the base of log both are same, that is simply equal to 1. That's a wonderful property, because see how difficult this question seems to be, but suddenly you realize that base as exponent and base of the log both are same, so that is simply equal to n. Okay. Uh, let's see one thing. E is also a constant. So if some property is working with number, it will also work with a. Log of E of n, that is also equal to 1. Or because log of E can be written as ln or natural log, so I can also write it E of ln of n, and that is equal to n. Perfect. Now this the property or the rule I am going to write now right now is a little bit tricky. So okay, just learn this, but we will use in higher level difficulty questions. Now suppose you have log of some base p a, and that is greater than log of same base p and b. Suppose that is the situation, right? So this implies if this situation occurs, so you can say that a is greater than or equal to p if p is greater than. As I told you, it's a little bit tricky, so you can just remember it. But okay, we will use it in higher difficulty level questions. I'm repeating it, I know. Okay. And if a is smaller than or equal to p, then p lies between 0 to 1. We know base cannot be 0, we know base cannot be 1. So that is why we have only written this sign but not this sign, right? So it lies between 0 to 1, then a will be smaller than b. So if you have to remember this property, so you can say, so if base is greater than 1, then inequality is same. You can remember it this way. Inequality is same, but if base lies between 0 to 1, right, it reverses. It reverses. Perfect. So here the properties are over. Just practice a little bit, and then in the next section we will solve questions based upon exponential and logarithmic, inverse functions, as well as base rule, and questions based upon the properties of logarithms, right? So let's meet in the next